So this session's called So Long and Thanks for All the Tests. Does anyone know what I'm referring to? No. So, does the machine work? Yes. Okay. So I'm referring to Douglas Adams. So Douglas Adams, famous for Life, the Universe, and Everything, and 42. And he made this statement in one of the early books, which is, so long and thanks for all the fish, is what the dolphins said to humankind just before they left the planet, just before the planet got destroyed. So what's that got to do with testing? Did the dolphins need us to give them fish? No. If they were intelligent enough to leave the planet, they could do very well without the fish. Do our applications need us to write tests? No. So the applications work just fine, or just the same, without the tests. So I want us to think about, do we want to write the tests or not? And I want to be very clear before I start that I like writing tests. And I think that we should write tests most of the time. And let's decide when is most of the time. So why do we write tests? To increase confidence. That's a great answer. So Jerry Weinberg, who is a consultant and generally wise man, who some of you may have heard of, wrote this book a number of years ago. It's a really interesting book. It's got a very humorous title, and Jerry is a very humorous writer. So I think this is a great book that you should think about reading. It's not just for testers. It's definitely for developers as well. But I think the important bit here is the little quote that I got at the bottom, which is that testing is a process of gathering information with the intent that that information could be used for some purpose. So I don't know about you guys, but I've been to a lot of places where we've got continuous integration servers, we've got unit and integration tests, and I go and ask them, I say, can I have a look at your integration build? And it's not passing. And I say, why is that? Oh, well, if I take that test and I run it on my desktop, it runs just fine. Or if we run it again, it works just fine. Or, oh, it sometimes does that. Okay, this is a really bad thing. So we're running all these tests, and we get the information that they're not working, and what do we do about it? We just ignore it. It'll probably go away. Just the other week, I was in a place, and it had been failing every day for 5 months. What's the point of even running it if you're not going to look at the output? So I think the first thing is that, yes, we want to get confidence in our software, but we run tests because we want to react to them when they fail. If we're not going to react to them when they fail, then there's not much point in having them in the first place. So that's the first message I want to give you. I also think that we need to consider whether the cost of keeping the tests green outweighs the value that the information gives us. So has anyone ever deleted a test? Good, excellent. Has anyone commented out a test? Yeah, so why do we comment out anything? So is there anybody in the room who doesn't use a source control system? So you don't need to comment things out. Okay, so I'm going to talk a little bit about developer tests. So I will talk to what's a unit test a little bit later on, but let's focus on developer tests. What are they for? So we had one answer already, which is confidence, and I'm going to say that roughly fits into the line of making sure the code works. What other reasons might there be for writing developer tests? So the ones that I've thought of up front, so you're not a good audience because you haven't fed me the lines in the right order, but there you go. So I think they're very useful for preventing regressions. So it helps us to refactor the code because it gives us even more confidence that we haven't broken something else by mistake. Documentation, I think, is a huge plus from writing developer tests. And the last one I've got on my list is driving out a testable design. So if there are people in the room who have ever taken a piece of code that doesn't have tests and tried to write developer tests on them, how easy was that? Often it is very painful. It does depend, but quite often you'll find that the code that you want to test might be dependent on some other subsystem the network, a file system, a database, all the things that you may not want to have running on your developer desktop, or in fact things that you can't run on your developer desktop. So the fact that you've written the developer test and they're working ensures that the design you've got is inherently testable. So let's go back to essentially the beginning of TDD, at least the beginning of its popular documentation. So this is a book that was written by Kent Beck. And Kent Beck, I guess he's kind of famous. He was the father of XP. He's been knocking around talking about unit tests and TDD for a long time, and a lot of other things. And this is not actually a quote from this book. This is a quote that he submitted in an answer on Stack Overflow a number of years ago. And I think it's a very interesting quote. I get paid for code that works, not for tests. So my philosophy is to test as little as possible. Now, I think that comes as a surprise to a lot of people. So Kent, the father of TDD, or at least one of them, is saying, I want to do as little testing as possible. And he goes on to say, but he wants to reach a given level of confidence and suspects that his level of confidence is higher than the industry average. How many of you think that the level of confidence you want to reach is higher than the industry average? Not many. How many think you're at the average? How many think it's way below industry average? Okay, not many hands going up for any of those, so I wonder what's going on. So let's go back to developer testing. What happened there? Am I going the wrong way? When do you write tests? Never. Anybody? Oh, only one person says never, or two. After writing the code? Loads, okay. At the same time as writing the code? Okay. Before writing the code. So there's a fair smattering of before, which may well be TDD, but it isn't necessarily. But most of you are writing the tests after the code. What are you trying to achieve when you do that? Coverage. Okay, we're going to revisit coverage in a wee while. I'm going to talk just slightly about TDD at the moment. Is there anyone in the room who has never heard of TDD? Good. Okay. So this is a picture drawn by Nat Price, more of him later, which is a nice graphic representation of the TDD cycle. It's known as red-green refactor. Red, you write a failing test. Green, you make that test pass. And refactor, you improve the structure of the code until you're happy with its quality and it meets all of your aesthetic and other qualities. So there are some important things about this. The first is that making the test pass, certainly the way TDD is described by a lot of the thought leaders to date, making the test pass, you should be making the test pass as quickly as possible. So some people call it shameless green. You try and make the test pass very quickly, not worrying too much, or if at all, about the quality of what you do to make it pass. Because now that your test is passing, you've got a framework within which you can refactor the code, and the tests should all stay green. And then the other bit that is often overlooked in the TDD process is refactor. You need to refactor. Refactoring is about cleaning up your code. We could go into analogies about keeping your kitchen clean, cleaning your plates, cleaning your knives and forks after you've had your dinner. But basically, if you're not refactoring, then you're not doing TDD. What you're doing is writing a test and then chucking out a bit of code. TDD's been talked about for years and years and years. Are there people here who think that TDD is something that they would like to try, but they haven't been allowed to at the place they work? No, okay. Have you all tried TDD? And what was the problem? Any? Time, okay. So that's quite a common answer. So I went out a couple of years ago and I did a little online research. And I did a web form and I asked people to say, well, why don't you do TDD? And the responses came back and they fall broadly into 5 areas. One was education, which was, no one's ever shown me how to do it, I really don't understand what I'm supposed to do. One was time, I haven't got enough time, my manager won't let me. A very important section was benefits. They were saying, I've never seen any evidence that TDD is beneficial in any way, shape or form. There was projects saying this is not suitable for my project. And there was cultural issues, which was along the lines of, my manager won't let me, my lead dev won't let me, this is not something that's going to be allowed in my organization. So it justified, or at least it explained to me why a lot of people, why there was such a small, low uptake on TDD. It also taught me a little bit about doing web surveys, which I'll share with you. Never put a free text box on a web survey, because it means you have to read every single answer and then try and analyze it. So this is what the general population said, and okay, it was only a sample size of 300 odd people, but nonetheless, I think it shows that there was a wide range of reasons for not practicing TDD. Strangely enough, though, there have been a lot of people over the past probably 10 to 15 years arguing why TDD is a bad idea in the first place. And more recently, I don't know if you caught the TDD is dead debate on the blogosphere, also on, I think it was on Vimeo, there was a discussion. So there were a bundle of people, Dan included, who said some things about TDD, but there's been a lot of people more recently who've been involved in a very heated debate about whether TDD is beneficial or whether it harms the design of your code. There's more in common with these folk than it looks like, so it's not a diverse bunch, is it? It's a lot of white males. But there we go. The question that was being debated and is still being debated is, should we do TDD or not? And what I'm going to try and convince you of is that that's not the right question to ask. So TDD is a tool. It's a way of working. And it may be good for you, it may not work for you. But nonetheless, absolutes are not going to help us here. It's not that TDD is bad. So how many of, so we heard a story this morning about swimming with armbands, and we also heard about bicycles. So has anyone ever fallen off a bicycle? Yeah. Does that mean the bicycle is broken? No. So just because something doesn't work for you now, it doesn't mean that there's something inherently wrong with the thing that you're using. It may be that you need to acquire a skill. There's something else that I think that's going on here. So these white males are speaking to the population, okay, the programming community. They're speaking to you. But who are you? Are you all the same? It feels like it's like something out of Monty Python here, Life of Brian. Are you all individuals? Yes, we are all individuals. So no, you're not all the same. So we heard this morning from Dan about the journey to mastery. And I'm going to echo that in some way. I'm going to bring out actually the martial art pattern of Shu-Ha-Ri. So here's an easier question. Have any of you seen Karate Kid? Okay. So there's that scene where he goes wax on, wax off. This is where the martial arts start. This is the mindlessly repeating the rules until you get the muscle patterns. And I think this is a lot of the problem in what's going on when consultants, thought leaders, developers, architects write blog articles that say absolute things. They're speaking to an imagined individual, and that imagined individual may not be you. That imagined individual may be a different place on the journey. So when Uncle Bob says, you must always do TDD, he's probably speaking to someone at the Shu level. He wants to give them clear guidelines of what to do to develop quality code. And when DHH said, TDD is rubbish, it hurts your design, he may have been speaking to someone that was up at the breaking the rule level or higher. How do you know that what they are saying applies to you and you should follow their advice? Partly, you have to decide yourself whether you are at the level that they're trying to speak to. And it's really difficult to know whether you're expert or not. So in the development languages and environments that you work in, how many of you consider yourselves to be experts? Not many, okay. How many consider yourself to be complete beginners? Okay. How many think you're quite average? Okay. By definition, I guess that's fair. However, so I'd like to also mention the Dunning-Kruger effect, which is which I won't go into great detail about, but essentially it's an effect which has been observed, which is people that are very good at something tend to underrate themselves, and people that are moderate or not very good at something tend to overrate themselves. So I've seen this in interviews. I used to work in an organization that used C++ for my sins, and we interviewed a lot of C++ developers. And when we would ask people to rate themselves between 0 and 10 as a C++ knowledgeable developer, a lot of the people I was interviewing would rate themselves 8. Apocryphally, Bjarne Stroustrup, the inventor of the language, rates himself at 7. It's a large, complex language, but it's just an example of the Dunning-Kruger effect. So Shu-Hao Ri basically says that at different levels of experience, at different levels of mastery, we respond to different messages, and we need different messages. And this was borne out later on in the 20th century by the Dreyfus brothers, who did another bundle of research and developed this model of skills acquisition. Of course, because the West is so much better than the East, we've got 5 levels rather than 3. But effectively, it's the same model. And how do you get from being a beginner, a novice, through to an expert? Or at least, how do you proceed up towards competency? I think, again, Dan gave us a lot of those answers this morning, and we get there by practicing, by doing things. To some extent, I think I disagree with Dan, in that I believe that the kata model does definitely help. And I'd like to introduce you, if you haven't already come across it, to this tool known as Cyber Dojo, which is an online development environment that you can use from any device connected to the internet with a browser. And here you, either individually or with groups of your colleagues, can practice katas in, I think at the moment there's 30 different development environments available on it. And it has some very nice features available that allow you, when you're working in a group together, to review each other's code, see the steps that each of the teams went through, compare your approaches to solving the problem, and go back and try it again. And the reason why I think this is useful is because you actually can fail in a safe way. You can take a problem and try solving it in your traditional way. Then someone can say, how about trying to solve it without using if statements? How about trying to solve it without using recursion? How about we try and solve it in this way? And you can iterate on it and work on your style and your technique in a very safe way that you can then review later. So that's deliberate practice, and it helps you get better at things. One of the things that I found that people notice as they're writing tests, when they're doing TDD, is that you get to a point where you go, actually, it was really hard to write a test for that. And that's a message that a lot of people ignore. If it's hard to write a test, that's telling you something about your protocols. It's telling you something about your API. It's telling you something about your design. And that something is that probably it's not a great design, or you could improve it. So the tests are speaking to you loudly. If you find that you're writing tests that have got a huge setup, if you're finding tests that are so complex that when you come back to them, you don't understand what they're doing, the chances are that you can improve the design of your code. So listen to your tests is a message that you'll hear from a lot of people. And another little book recommendation as we go through is this wonderful book by Nat Price and Steve Freeman called Growing Object-Oriented Software Guided by Tests. And they talk a lot in that about listening to your tests, about starting with a test that specifies the behavior of the system that you want to develop, and in response to that, writing code that delivers that behavior. Now, this relates to TDD and our previous discussion of developer testing, because Nat and Steve are very clear that they are actually writing their tests at a higher level of abstraction. So I showed you the red-green refactor diagram from Nat, but he also drew this diagram. And this one shows an inner and an outer TDD loop. So the outer loop is essentially acceptance tests or system tests, and he's writing those to describe the behavior of the system, actually as it works in practice. And then when you've specified a behavior of the system, you can drop down a level and start implementing the code that will do that in the micro level, at the actual implementation details. So you have at least 2 loops that are driving your design and driving your testing. This inner loop is often called unit testing, and the outer loop is often called acceptance testing or systems testing. So I think it's now time to visit these definitions. What are unit tests? What are integration tests? Has anyone seen this diagram before? No. Okay, this is known as the testing pyramid. So it's misnamed because obviously it's a triangle, not a pyramid. And at the bottom, we have tests that verify components in isolation. So to use an analogy with a motor car, these would be tests of the little components within the car, the brake cylinder or the indicator light or the ignition. Then moving up, we have tests that verify the integrated subsystems or components. And here we can think about the cooling system, the engine, the steering rack. Finally, we're going to need some end-to-end system tests. And here we stick the car on a ramp, we drive it and make sure that it accelerates and it brakes. And every pyramid, as you know, has a cloud at the top of it. And at the top of this cloud is the one that says exploratory and manual testing. And this is an important one because we need to remember that just because we're writing automated tests doesn't mean we're covering everything. We've only got a certain, we only have certain things that we can automate, and there's always going to be a case for automated and manual testing. So don't fire your testers just yet. And here the analogy is with taking it out on the track and crashing it into things. So I'm saying that unit tests are a bit like brake cylinders or indicators or ignition cylinders. So can we think of a better definition then for what is a unit test? Anyone would like to offer a definition of a unit test? Excellent. Any others? So that's an interesting one. I think I'm not going to take that one on board just yet. So your colleague said that test the smallest possible component. Any others? Okay, so actually defining what is a unit test is notoriously difficult. So Michael Feathers, who's done a lot of work in that area, chose to do it the opposite way round and define what things that aren't unit tests. So in a blog post a few years ago, he wrote that it's not a unit test if it talks to databases or the file system or talks over the network. And what he's trying to show there is that what we need to do is be able to run something in isolation. Why do we want to run something in isolation? Well, because we'd like it to be repeatable. So for instance, a test that talks to the file system can fail for a number of reasons. Some of them may be because you've put errors in your code. But one of them could be that the disk has gone down or has filled up. Tests that won't talk over the network can fail because you've made a mistake in your code or because somebody has unplugged the network cable. So these tests, I think probably the essential element of a unit test is that it can be isolated from other dependent systems. And this leads us back to a statement that Ian Cooper has been making and made at NDC a couple of years ago. That the behaviors that we test should be at the behavioral level, and they shouldn't be testing implementation details. So there's rather a lot of text on this slide, but essentially what we want is tests that remain good even when we decide to change how we implement the code that delivers the behaviors we want. We don't want to go and have to fix 10,000 tests because we've decided to move from a list to a queue. And if we find that these tests are breaking, it means that our tests know too much about the implementation of our code. So what we're trying to do is ensure that we specify the behavior in our tests, not specify or tie down the implementation. So our tests need to be as loose as possible to ensure that we deliver the value and the behavior that our customers need. And in customers here, it could be your end user customer, it could be another part of the code that needs behavior from your API. We're just trying to tie it down. And if you find that your tests are slowing down your development, it's probably because you have got too many detailed, low-level tests that are tying your code down to a particular shape to a particular implementation. So over the years, I've tried to catalog, or at least classify, the qualities, the properties that I think a good unit test should have. And they come down to this list in no particular order, just an inverted pyramid size in English. So I think tests should be understandable. And so this goes directly to your point about documentation. We want the test to document what the code does. If we can't understand what the test is trying to do, then it's not going to be very useful as documentation. Maintainable goes directly to my point about not coupling to the implementation, but trying to assert and specify the behavior of the component. So when we change parts of our system, we want it to be easy to maintain our tests. We don't want to spend just as much time fixing broken tests because we're not affecting the behavior that those tests we're trying to specify. We've talked about repeatable. They need to be able to repeat over and over again and always pass or always fail. We don't want flickering tests. And this leads us to want a testable design. This leads us to think about techniques such as dependency injection or inversion of control to ensure that we isolate ourselves from networks, file systems, or the system clock even. Necessary plays to the do you delete your tests ever? So if the specification is no longer valid, then you can go and make sure that there are no tests there that still assert it. You go back to your tests and you refactor them like you would refactor any other piece of your code. If you see repetition, if you see tests that are not adding value, feel free to delete them. Granular is a slightly more difficult one, I guess, to define. I think each test should specify and assert a single behavior. Now, note, I'm not talking about specifying or having only a single assert statement in them, because sometimes you need more than one assert, but they should only specify a single behavior. If you find in your test names that you're using words like and, then you've probably got more than one behavior in that test, and think about splitting it out. And the reasons for that are many, but I think the most important one is that when a test fails, you want to know really quickly why it failed. You don't want to have to go and dig into the code and try and see what the reasons were, because it's a very complicated test. You want a simple test that specifies a single behavior, and when that test fails, you know that something has gone wrong around your implementation of that behavior. And fast is essential. So for those of you that have written unit tests, how often do you run them? Do you run them as you type? One? A couple? Okay. Do you run them before checking? More? Do you wait until they hit your source control system or your CI server? Not many. Okay. Do you wait for the nightly build, the weekly build, the monthly build? So the point here is that we're trying to get feedback, and we want the feedback to come as quickly as possible. If the tests take a long time to run, we're going to run them less often. We're going to start doing work before we get the feedback from them. We'll end up putting in other problems on top of a code base that already has a problem on it. So we need to keep the test fast. If the tests aren't fast, then the feedback comes in slowly, and then we can't respond to it in an efficient way. So these are 6 properties. Roy Osherove, in one of his books, identified 3 properties, and he called them maintainable, trustworthy, and readable. I think that follows the same sort of pattern. Emily Bache has got 4. She talks about coverage, readability, robustness, and speed. So I came up with 6. Roy Osherove, in his latest version of the same book, has identified 9. So clearly the competition is on. We're going to have to find a 10th one. But nonetheless, we're all talking in the same space. We need to be able to understand the code, the tests. We need to be able to maintain the tests. We don't want them to break. We want them to be deterministic and repeatable. And we need them to run quickly. So how do we test components in isolation? We've already talked about it. I've certainly already alluded to it. And the answer, I believe, is a concept, again, that Michael Feathers came up with. It's called seams. So a seam is a point in the software where you can substitute one component for another. So dependency injection is one form of seam. You can have compile time seams. Some languages allow you to have link time seams. There are lots of different seams that you can use, and they depend on your development and runtime environment. They are extensively documented in Michael's book. This is one called Working Effectively with Legacy Code. It's a hugely important book. Most of us work with legacy code. Michael's definition of legacy code is code that doesn't have tests. So there's a lot of it about. It's nothing to do with how old it is. So certainly not according to Michael's definition. So code that you write today, if you haven't written the tests, if you say, I'll do that next iteration, which I've heard a number of times, then that effectively is you've committed legacy code to your repository. So I believe that this book should be on the bookshelf of every development organization, and I highly recommend you have a look at it. But at these seams, one of the most common ways of introducing an alternative implementation is by passing in a test double. And test double is a messy concept. And Gerard Meseros, in this book, The X-Unit Test Patterns, I think, tried to get a taxonomy of test doubles. And I won't go into great detail here. Again, the slides will be online. But there are dummies, fakes, stubs, and mocks, essentially the four that he divides them into. And your dummies are where you just put in some sort of object to satisfy the constraints of your type system. A fake is something that is slightly simpler or runs faster than the production version of that object or component. A stub provides a canned response, and the mocks are much more complex behavioral objects that allow you to specify how objects interact with each other. Now, the problem here is that Java and C# have now got very powerful mocking frameworks, and people will use those mocking frameworks even when a dummy or fake or stub would do. Now, these mocking frameworks are fine for creating dummies, fakes, and stubs. There's no problem there. But because you've got all the power of the mocking framework, developers are often tempted to over-specify and use mocks in more powerful ways than are demanded for by the test. So I don't want to go into detail about mocking. One, because we're rushing towards lunch and it causes indigestion. What I do want to point out is that Java in the nutshell, when it first came out, had less than 600 pages. Java in a nutshell now was 1,256 pages. And getting these things into nutshells is quite hard. I had a look at the Mockito ref cards, so a cheat sheet of compressed information. It runs to 6 pages. So when a cheat sheet is cheat sheets, we know that obviously it's doing lots of good stuff that people like, but there's a lot of power there, and a lot of the time you don't need to use it, and you possibly shouldn't use it. So I'm going to make 2 statements about mocking. Mocking can make a terrible mess. If you've ever looked at unit tests that have got 2.5 screens worth of setting up your mocks and expectations, you'll know what I mean. You look at it and you go, what on earth is going on here? And at that point, the readability has entirely disappeared. And you have to ask yourself, what could we have done differently in the design of our software to remove the need for all of those mocks? The other thing that I'd like to say about mocks is that they can give you a full sense of security. Because in a mock, especially when you're using it in full power as a behavioral concept, you are saying to it, behave like this. And that means that you are claiming that you know how the system that you would be interacting with will behave. And if, when you actually release into production, the system that you're working with behaves differently, the things that worked perfectly well in test are going to fail in production. That's never a good thing. So along the bottom, I've got a link. Well, it's not a link as such. It's on the Goose mailing list. It was a mail from J.B. Rainsberger. And he, in this mail, describes his attitude and approach to trying to get around this problem of full security. And it's to do with collaboration and contract tests. Again, I'm not going to go into it here. Please go and have a look at that online. So, let's have a thought experiment. How valuable are your tests? If you were given the choice between deleting your production code or deleting your tests, which would you do? So there's a production code. Would you like to explain that one?
I can recreate all my production code if I have a need flow.
So that you can recreate your production code. So this is a thought experiment. So obviously, I'm not suggesting you delete either of them, but the intention is that your tests not only document but specify your production code. It was a thought experiment that Uncle Bob came up with. Again, another book, another week of reading. This is a wonderful slide. I think, Dan, do you recognize this one? Familiar. It's a shame because Dan's talk today, he was using proper typed stuff, but there was a period earlier this year or last year where all of his talks were hand drawn on index cards, which I really liked. Anyway, so this is a wonderful slide. In fact, a wonderful pair of slides. And the reason I stole this is because it really pushes us towards a nuanced thought about where should we be putting the effort of doing the tests. So if a component is not likely to fail or doesn't have a low impact when it does fail, how much testing do we need to do there? And contrast that with a component that has a high likelihood of failing and has a huge impact when it fails. How much testing should we do there? And the next slide happily goes, is 80% testing enough in the top right-hand corner? Or is 80% coverage too much in the bottom left? I leave you to answer those questions yourselves, because essentially it comes down to your context. What does it mean? How much time have you got? What's your appetite for risk like? But I did say we'd come back to coverage. Who thinks coverage is a good metric? Really? Only one. Okay. No. Are you all lying? Is there a better metric? There is no metric. Okay. There is actually a metric that is better than coverage. I'd like to introduce any Java developers here to PyTest, which is a mutation testing framework, which works on an entirely different principle of injecting faults into your software, into your production code, and then running the unit tests to see whether they fail. And so just run this around in your head afterwards. If you inject a fault and your unit tests don't fail, how good are your tests? And it's around risk. So let's wrap up with another book recommendation with the wonderful title Waltzing with Bears. It's an old book, but I think it's essential reading, certainly for anyone who wants to move on in the software development chain of command, maybe I should call it, to really get an understanding of what estimates mean, where you can address risk, how you can work with your customers and your business to have a meaningful collaborative discussion without making promises that you can't deliver on. So certainly Liz Keogh quotes one sentence from the introduction, which says, if there's no risk on your next software project, then don't do it. Because actually that's our job. Our job is to take on risk. We have to try and deliver something that somehow mitigates with some risk. So, this has been a whirlwind talk through because we need to get around for lunch. The message, I guess, at the end is, please don't panic. Probably the way you're working at the moment is right for your development environment. I hope I've given you some things to think about in the realms of, could I do more testing? Could I do less testing? Should I be doing any testing at all? I've certainly hoped that you'll take away Cyber Dojo and the idea of deliberate practice. As a recap, the developer tests are there for making sure the code works, for preventing regressions, to document what it does so that you and your colleagues, when they come back to the code in 2 months or 2 years' time, will understand why you did it, and for driving out a testable design. And the things that seem important to me is that us as developers, we should be looking for value. We should be delivering what our customers need. We should identify the risks and behave appropriately. So that's a context-dependent thing. And so you need to understand your context. Finally, if the tests don't make your life easier, then there's something wrong with the way you're going about it, or there's something wrong with the architecture that you're working with. The tests are there to make things better. If you're tearing your hair out and you're going, this is awful, then we need to go and have a look at why that is. because that's A, not the purpose of the tests, and B, it's not necessary for tests to be like that. So I have been very happy to talk to you. Thank you very much for inviting me. If you're working in Java and you work using Cucumber, then the book that I've ported from the Ruby is currently in beta. So I'd encourage you to go and have a look at it and send me comments. And those are the details of how to get in touch with me. Thank you very much.